Welcome to yet another episode where we shall be looking at the possible or suggested memorandum for the Mathematics Paper 1, May-June 2025. Okay, so the paper was a 3-hour paper. Those were the instructions. And we have our first question. Okay, so the first question was telling us to solve for x. So looking at 1.1.1, it's just two terms that we are dealing with. So in this case, we just have to take out what is common. Okay, remember it's a quadratic. So if I take out the x, I'll be left with 3x plus 5 is equal to 0. And then I'll use my dot product, which means x is a 0. Oh, my x is going to be negative 5 over 3. So those are the two marks or the two answers for that first part. And then 1.1.2, we're being told that 4x squared plus 3x minus 5 is 0. Now remember I said for as long as we see this bracket there of two decimals, which means we have to use a quadratic formula. Okay, so I'll just do this on the other page. So we have 4x squared plus 3x minus 5 is equal to 0. So our a is a 4, our b is a 3, and then our c is a negative 5. So what I'll do, we know that from the quadratic formula it's negative b plus minus the square root of b squared minus 4ac. Everything is divided by 2a. If I try to do the substitution, that's going to be negative 3 plus minus the square root of I have 3 squared minus 4 times my a, which is a 4 again, and then my c, which is a negative 5, and then I divide this by 2 by 4. Okay, you can go on and try to simplify that further or break it down. So this would give me something like a negative 3 plus minus. When I look at the root sign, that's 3 squared, which is a 9. Okay, 3 squared is a 9, and then I'm having 4 by 4, 16 times 5, that is 80. So in other words, I'm adding 80, so I'm going to have root 89 over 8. Okay. So when I punch this into my calculator, let's see. Okay, so I'm ending up with x being a negative 1,55 to 2 decimals, or x is a 0,80. So these are the two answers that I'm getting for that particular sum. 1.1.3, you're being told that x minus 1 squared minus 9 is greater or equal to 0. So this is the inequality part of the question. I'll still do it on this other side. So it is x minus 1 squared minus 9 is greater or equal to 0. Okay, so there's two ways to answer this. You can either open up this bracket and form a standard equation of the quadratic, or we can just move the 9 that side, and either way, okay, our aim is to end up with the critical values. So let me shift the 9 to the right hand side. So it's x minus 1 squared is greater or equal to 9. And then I'm going to find the square root on both sides. Okay, square root, so it means x minus 1 is greater or equal to plus minus 3. Because square root of any number must give us two values, a positive and a negative. So what will my critical values be? It's plus minus 3 plus 1. So which means the first critical value can be a 4. The other critical value will be a negative 2. But now, since our a is greater than 0, and the symbol, the inequality symbol, is also greater, which means x must be less or equal to the smaller value, or x must be greater or equal to the bigger value. For candidates that prefer to use the diagrams of the parabola and things, if I'm to sketch my parabola, I'm going to end up with something like this. This is a -2, and then this is our 4. Now they're asking us for values that are greater. So we can shade off this section or shade off that section, because that is the area or the region of interest. Or you can alternatively use your number line. That's going to be a -2, this is going to be a 4, and then you just indicate with the arrows in that sort of direction. So that is what one would have done for that particular question, 1.1.3. Then the next part, 1.1.4, these are exponents, 4 marks. Question looks simple. I don't know why they're giving it a lot of marks, but there could be a reason. So we could use the K method for this particular sum, okay? But let me just use the quick one. So what I can see, there's a 5 to the x and a 5 to the 2x. I can factorize out the 5 to the x. And then I'm going to be left with 5 to the x minus 1 is equal to 0. Let me do it this side nicely. We have 5 to the 2x minus 5 to the x is equal to 0. So we said take out the 5 to the x. We have 5 to the x minus 1 is equal to 0. So it's a dot product. So either the 5 to the x is a 0, or 5 to the x minus 1 gives us a 0. But under exponents, there is not a thing whereby you raise a number to a certain exponent and you end up with a 0. So this doesn't exist. So no solutions for the first part. And then with the second option, we can move the one that side, so that 5 to the x is a 1. The only scenario where we end up with a 1 is when a number is raised to the exponent of 0. So we're going to say 5 to the x is the same as 5 to the exponent of 0. So the bases are the same. You drop them, so x becomes a 0. So that is how this question would be answered. Alternatively, if I'm to use the K method, someone would say, let 5 to the x be a k. So that's going to be k squared minus k is equal to 0. And then k, you factorize it out, you're going to be left with k minus 1 is 0. So either k is a 0 or k is a 1. And then replace the k with the 5 to the x. So 5 to the x is a 0 or 5 to the x is a 1. And then you go back to the same scenario, the same step. So we have no solution for the first part. And then in the second part, x will be a 0. All right, we move on. 1.1.5. 1.1.5. So this question was rather interesting, okay? Because it is just direct the way it is. There's not much of things that you have to do or to stress about. Okay, let's see. We're being told that the square root, it's x over the square root, okay, of 20 minus x is equal to 1. So these are equations that involve surds. One thing we said, we need to isolate the surd, leave it on one side of the equal sign. So in this case, it's having something with it. So since it's a fraction, I'll just cross multiply or multiply both sides by that root sign. So x will be the same as square root of 20 minus x. That is the first step. We've isolated it. The next step we said was to square both sides so that we get rid of the root sign. Okay, when you do that, we're going to end up with x squared is equal to, the root sign falls away, that's 20 minus x. Then create a standard equation, that's going to be x squared plus x minus 20 is equal to 0. Okay, so if that is what we have, remember we have two options. It's either we can do the factors, or we can alternatively use the quadratic formula. Either way, whichever one you're comfortable with. So I'll have x, and x can have 5 and a 4. I'm going to make this a positive and that's a negative. So my x here is going to be a negative 5, or x is going to be a positive 4. Now remember what we said, in such cases or in such scenarios where you have a sad equation or sad form, or equations in the sad form, you have to test your answers. Okay? If you fail to test, you're going to lose the last mark. So if I use negative 5, because testing is done using the original expression. So I'll have a negative 5 over, I have 20 minus 5, which is going to give me 25. So we know that the square root of 25 is going to be 5. When you simplify that, you're going to get a negative 1. In this case, we have a positive 1. So this is not applicable. Okay, we can cross this out. It's not a solution to that equation. Then let's try out 4. If I substitute a 4 there, I'll have square root of 20 minus 4, which is 16. Square root of 16 is a 4. So that is 4 over 4, which is a 1. So this solution stands. So that is 1.1.5. 1.2, beautiful. X plus y is a 9, 2x squared minus y squared is a 7. So remember, if this is equation 1, this is equation number 2. We said use the linear. This is the linear. Try to make something the subject of the equation. So if I have x plus y giving me a 9, and then I'm having 2x squared minus y squared gives me a 7. That's correct. So from equation 1, okay, I'll say, let me make y the subject. So which means my y is going to be 9 minus x. I'll call this my equation star, or equation 3. And then I'll substitute my equation star into equation 2. Where there is y, I replace with that. So that's going to be 2x squared minus 9 minus x squared is equal to 7. When I open this up, 2x squared, remember this is a square bracket. So that's going to be 81 minus 18x plus x squared should give us a 7. Okay. Open with a negative sign, it's going to be 2x squared minus 81. That's going to give me 18x. That's minus x squared is equal to 7. I simplify this with the like terms. That is x squared plus 18x. When I bring this one that side, what am I going to end up with? Okay, so that is 18x. Am I on the same track? Are we on the same? There's something we missed out. There's a 2 in front of the y. Where is it? Why am I just saying y squared? No, there's no 2. It's just 2x squared minus y squared. Perfect. 2x squared minus y squared. No, it's okay. So I'm going to move the 7 to the left hand side. Okay, so it's going to be a negative 88 is equal to 0. Negative 88. Okay, then I will reuse my quadratic formula or my factors. Let me see what I get from my calculator. Need to see. Okay, I'm going to use x. I'm gonna use 22 and 4. Okay, since this is a plus, this is a minus, is equal to 4. Okay, so which means x is a negative 22 or x is a 4. Then I'll get these values and I use that equation star. You said 9 minus. Okay, so if I use this one for the first part, that's gonna be 9 minus 22, which gives me a positive 31. Or y is going to be a 5. So guys, those are the solutions for that simultaneous. Alternatively, remember, someone could also make x the subject by saying x is the same as 9 minus y. So it's going to be the same story or the same approach, and you should end up with just the same values, okay, for x and for y, regardless of which option you've decided to use. Okay, so guys, that is that. 5 marks in the bag. 1.3. This question is a bit tricky. Okay, they told us that P is 1 minus A. And then T is the product of 1 plus A, 1 plus A squared, 1 plus A to the 4, up until 1 plus A to the 5, 1, 2. They want the product of P and T. So what I'm seeing is that if I get this multiplied by that, I'll have 1 minus A into 1 plus A, then 1 plus A squared, and then 1 plus A to the 4, and then the story continues. Okay? But I know that this bracket and this bracket is a difference of 2 squares, okay, which is the same as 1 minus A squared. Now, when I simplify this, it takes me back to that, and then the expansion just continues. Still, this bracket and this bracket is a difference of 2 squares. So in other words, it's just a repetition of difference of 2 squares continuously. So this is going to be 1 minus A to the 4. And then you continue. You're going to have 1 plus A to the 4. And so on and so forth. Now, since the last term, or the last bracket, is 1 plus A to the, which means all these brackets are just going to reduce to something like 1 minus A to the 5, 1, 2. And then I'm having 1 plus A to the 5, 1, 2. So it's still a difference of 2 squares. I'll have 1 minus, and then I just add up those things. Since I'm going to multiply numbers with the same bases, I'll add up the exponents. So we know that 5, 1, 2 times 2 gives me 10.4. So this would be my answer for that particular part. So it's 1 minus A to the 10 of 10.4. That's the answer for 1.3. So guys, those are 26 marks. We move on to question number 2. Number 2. 2.1, consider the geometric series. Okay, we have 4 plus 2 plus 1 plus a half, and so on and so forth. Does this series converge? Just for your answer. Now remember what we said under the prediction and the notes before the previous videos. We say that for convergence to take place, okay, there is this condition that needs to be fulfilled. And the condition is that -1 must be less r and less +1. In other words, our common ratio must be between -1 and 1. So what we're going to do in this case, we need to find the common ratio. And if indeed the common ratio is between -1 and 1, then this series will converge. So what we're going to do, we know that for us to get r, we can use T2 over T1 or T3 over T2, just in that format. So if I use 2 over 4, which is going to give me a half. So a half is 0.5. So 0.5 lies within this range of values. So we're going to say answer is a yes because -1 is less a half and is less than 1. So it's within that range or that interval. Okay? And then 2.1.2, they're asking for the sum to infinity. Now, this was just an indication. Okay? The moment they ask for sum to infinity, which means the previous answer was meant to be a yes. and you just give a reason. Okay, so sum to infinity, we know the formula is a, which is the first term, over 1 minus r. Our first term is a 4 divided by 1 minus the common ratio, which we say is a half. So that's going to be 4 divided by a half, and then our answer is 8. Answer is 8 straight away. So those are 2 marks as well. 2.2, we are given a sigma notation. Sigma notation. How would we determine the value of k for 5 marks? Let me use this side with proper space. Okay, so we have the sigma p is equal to k into 3 to the p minus 1. We're going up to the 10th position, that is 29520. It's not the 10th position, but the 10th element of interest. Okay, so whenever we see sigma notation, what comes into our mind should be the sum or the summation of terms. But with the same token of appreciation, when you look at this component here, it says a lot about the type of pattern that we're dealing with, or the type of sequence that we're dealing with. So in this case, we're dealing with a geometric sequence. Okay, so how are we going to play around with this? Number one, I'll need to find my first term. That is when p is equal to k. So I'm going to say t1 is going to be 3 to the k minus 1. That is my first term. Then, from the general term of a geometric, we know that it's ar to the k on m minus 1. So chances are high that this r is being represented by the 3, which means our common ratio is a 3. Okay. If that is also true, we need to also find out how many terms do we have within this kind of statement. So remember, to get the number of terms, you get the upper limit, which is a 10, minus the lower limit, and then you plus with a 1. So I know that 10 plus 1, that's going to be 11 minus k. So these are the number of terms that I'm dealing with. Then I'll go use my geometric formula, or the sum of the geometric, which is given as a into, I'll use r to the n minus 1 over r minus 1, because I know that my r is greater than 1. Okay, so the sum, they gave it to us as the 29,520. I'll put it aside. My first term, we got it as 3 to the k minus 1 into, now we say the common ratio is a 3. And the number of terms, we said it's 11 minus k. And then we need to subtract our 1. We are dividing this by 3 minus 1. Okay, so this should give us the answer straight away. Okay, so simplifying this denominator, I'm going to end up with a 2. And then I'll multiply. Remember, we're saying this is going to be a 2. Then I'll multiply this 2 by that. What we get, calculator. Calculator is giving me 59. Okay, 040 is equal to 3 to the k. That's fine. Let me open up. Let me open this up. And open this up. Yeah, let me open it up. So I know that this base is the same as this, so which means I'll have to add up the exponents. So that's going to be 3k minus 1 plus 11 minus k. Minus 1 times that, it will be just the same thing. Okay. So 59040 is equal to, this k cancels that k, I'll be left with just 3 to the 10 minus, this is going to be 3 to the k minus 1. Then I need to move this to that side. Okay. 3 to the exponent of 10. I'll have, let's see, this on my left is going to be 59040 minus 3 to the 10, I'm getting 59049 is equal to the negative 3k minus 1. So these numbers are the same except for the last part. So I'm going to have a negative 9 left here, having a negative 3 to the k minus 1. Divide both sides by a negative. I'll be left with 9 is equal to, let's just increase that so that everyone can see. Okay, so that's 9 is equal to 3 to the k minus 1. You can change the bases, you can use your logs, whichever format you want to use. So 3 squared is equal to 3 to the k minus 1. Bases are the same, focus on the exponents, which means k minus 1 is equal to 2, which means k is a 3. Okay, so that's how I would have gone about with that question. Okay, that is 2.2. Then question number 3 is still a sequences and series, but they're telling us we must consider this quadratic pattern. Can we show that the general term of this pattern is given by this? So remember, by virtue of definition, quadratic pattern must have two differences. Okay, so we know that for us to move from 4 to 7, that's a plus 4. Sorry, from 3 to 7, plus 4, and then that is a 5. Which means our second difference here is just a 1. So this one is being represented by 2a. Divide both sides by 2, which means a is a half, okay, which we have it here. And then we know that 3a plus a b must give us the first term of the first difference, which is a 4. But our a is a half, so which means b is going to be 4 minus 3 over 2. That is 5 over 2. Okay, I'm replacing a with a half, which will be 3 over 2, plus a b must give us a 4, and then I transpose. Okay, so that's our b, which is here. Now let's confirm if there is really no c. If I get a plus b plus c, I should be able to get this first term, which is a 3. So a is a half, b is 5 over 2 plus c is equal to 3. So this can be simplified to a 3 and the 3 cancels, c is a 0. So therefore, Tn becomes a half n squared plus 5 over 2n. So the aim of this question is just to really check if learners know how to determine the a and the b and the c. Basically, they were not asking for the Tn because they have already given it to you. Okay, then 3.1.2. What number must be added to the Tn minus 1 so that the Tn is that? Wow. Now, when you look at this question, okay, it looks tricky, but it is simple, very direct. Remember, if you talk of Tn minus 1 and Tn, it's like these are consecutive terms that are just one after the other. Let me just write this, that's on the next page. This is 3.1.2. Okay. 3.1.2. So we're saying we started with a 3, a 7, a 12, and so on and so forth. So we're going to have a scenario where we have a term that is Tn minus 1, and then we also have a term that is 13,527. 13,527. Now the question is asking us what number must be added. Initially, the first differences are all about additions. Why am I having a 5 here? This is a 7, and then a 12. So this is a 4, and then that's a 5, and so on and so forth. So we are just adding. In other words, which number do we add here to give us that? So 2 ways to do this. The first approach is for us to get the position of this 13527. Okay, for me to get that, I'll apply my Tn, where we said it's a half n squared plus 5 over 2 n. Then I'm going to equate it to 13527. So this is a quadratic, so it's a half n squared plus 5 over 2n minus 13527 is equal to 0. If I use my quadratic formula, a is going to be a half, b is going to be 5 over 2, c is going to be negative 13527. Okay, this is the, I don't know, I will call it a longer approach. Then when I use the quadratic formula, I'm getting n to be either negative 61 or n to be a 61. But remember, positions, no, not 61. Who's mentioning 61? It's 162 and negative 162. Okay, so negative 162 and a positive 162. We can confirm that again so that we are on the same page. Minus 13527. What do we get? That's negative 167 and then a positive 162. Now remember, position of terms can never be negative. Okay, so this is not applicable. This negative 167. So what we are left with is 162. Now, if we have 162 as our position, the number that they are talking about here will be 161. In other words, the position will be 161 for the Tn minus 1. Okay, and if that's the case, just get this 161, substitute it into the Tn. Let's get the value and let's do the subtraction. So I'm going to say 161 is going to be a half times 161 squared plus 5 over 2 into 161. Okay, so I'm ending up with 133. What's happening with my pen? 13363. And then the difference is going to be 13527 minus 13363. And this gives me 164. So this is the answer that they want. This is the number that must be added to the Tn minus 1 to give you that. There is a shorter way. There is a shorter way. And the shorter way is to use the arithmetic pattern. Okay, the first difference is if we can get this number straight away. Straight away. So how do we go about that? It's of course going through this quadratic, and then you get your 162 as the option. Then what that means is that in this position of the arithmetic, the position of this one is going to be 161. Okay, then if I look at my Tn, you know that it's a plus n minus 1 into d. Our first term was a 4 minus n minus 1. Our common difference was a 1. When you simplify that, you'll just have n plus 3. Okay, so remember we said our Tn is 161, the position, or not the position, the term itself. So that's gonna be 161. That's 4n plus 3. He said 162, 161. That's correct. I don't know how I'm failing to get the 164, but it should be around that. No, it's already done. It's already done. Because what's going to happen is that we're looking for the Tn in a position of 161. Okay. So we're saying Tn. Okay. Tn is going to be Apologies, guys, my pen is acting up. Okay, so we're saying the position is 161 plus a 3, and then that gives us 164 as our answer. Okay, so for as long as we get the position of the 13, 5 to 7, and then the rest is just an application. Okay, so that is 3.1.2. 3.2, they are telling us that we are given an arithmetic sequence with T1 as 8, T2 as 11. They want us to calculate the value of n if Tn is 41. So this is more like a simultaneous, if I may say that, because if T1 is 8 and then our T2 is 11, we know that from an arithmetic a plus n minus 1 into d. So that's going to be 8 plus, but why am I going this way? A is 8. We know that T2 is the same as a plus d. So a plus d is equal to 11, whereby our a is 8. So 8 plus d is 11, which means d is a 3 straight away. Okay, that's the first term. A second term is a plus d. But you can go via that shorthand. You're going to end up with the same thing. Okay, so if d is a 3, a is 8, they want us to get n if Tn is 41. So if Tn is 41, let's do the substitution in the general term of an arithmetic now. Okay, so 41 is equal to 8 plus n minus 1. We say d is a 3. Okay, I'm going to move the 8 that side. So 41 minus 8, from my calculator, I'm getting a 33, is equal to 3, n minus 3. Move the 3 that side. 36 is equal to 3n. Divide both sides by 3, which means n is a 12. Okay, so n is a 12 for that part. Then 3.2.2 is a new pattern, that is p, using the term position and the term value, which means P8 is 1, P11 is 2. In other words, things are being switched around. Chances are high this is going to be having some bits of fractions. Okay, they want us to get P41. We just switch the values. So I'm going to say P41 is a 12. Because if n12 in the first sequence is giving us 41, which means P41 must be a 12. That's why it's even 1 mark. Okay, then part B, calculate the value of the first term of the new arithmetic sequence. So what we do with this, just try to go through just the same sort of process. What do they want? They want the first term. So I will go down and say that instead of using Tn, I'll just call it a Pn. Remember, it's arithmetic, so there's not much of a difference. Okay. What were we told? We were told that P8 is a 1. Okay. So where there is n, I'll replace 8. Where there is Pn, I'll put a 1. So 1 is equal to a plus 7d. But also they told us that P11 is a 2. So if I use P11 to be a 2, that's going to be 2 is equal to a plus 11 minus 1. That's going to be 10d. Call that equation 1, call that equation 2. Let's subtract 2 minus 1. So 2 minus 1, that's a 1, is equal to a, cancels out. 10 minus 7 is a 3d, which means my common difference is a third. Okay, which means we are adding or subtracting a third every time the question wants the a value. So I can use equation 1. Okay, substitute d into equation 1. So 1 is equal to, why don't I just say that a is equal to 1 minus 7d straight away. Okay, so 1 minus 7 times a third, which is 7 over 3. What a value are we getting? I'm getting negative 4 over 3. So that is the a value that I end up with. That is 3.2.2 part B. Okay, I move on to question number 4, which is the functions. And we're being told that g of x is 1 over x minus 1 plus 2. Write down the equation as synthesis. So before we even start, we need to know what type of graph is this. Okay, now since the x is by the denominator, this is a hyperbola. Okay, hyperbola. Now we know that with the hyperbola, asymptotes are just the bottom part and then the isolated constant part. So you're going to say x is a 1 and y is a 2. Switch the sign of the x, leave the y as the way it is. Then they want us to draw indicating all intercepts or any intercepts and then asymptotes. So the only part that is really missing out here could be the intercepts. We can say that for y-intercept, x must always be a 0. Let's replace x with a 0 here. It's going to give us a -1 plus a 2, which is a 1. So which means the graph is passing through 0 and 1. Then let's get the x-intercept. So x-intercept is saying y must be a 0. G of x is the same as y. Replace a 0 there. So 0 is equal to 1 over x minus 1 plus a 2. Let's move the 2 first. So that's going to be -2. It's 1 over x minus 1. Cross multiply. Let's cross multiply. That's -2 into x minus 1 is equal to 1. When you open this up, -2x plus 2 is equal to 1. Move the 2. -2x is -1, which means x is a half. So you're going to have a half and 0. Please just try to show us how you get this intercept. You can give you a mark for that. And then for the y-intercept, just use a calculator straight away. So these are the 2 points of interest. And what is left is just for us to sketch. So I'll try to just squeeze my graph down here. Okay, if that is my y, this is my x. Remember with asymptotes, we said x is a 1. So if I take this to be my 1, and then y is a 2, I'll just indicate it here. My asymptote to be a 2. And then it's passing through 0 and 1. 1 is halfway there, and then half is somewhere there. But our A is positive, which means we expect the graph to be in quadrant 1 and quadrant 3. So you're going to have this here. There are no points, just sketch. And then this must pass through that. So the graph must just continue in that format. So this is our G. Okay, so that is how the graph would be sketched. And then 4.3, determine the values of x where g of x is above 0. So the g of x is greater than 0. In other words, it's above the x-axis. So the graph is only above the x-axis from this point. If this is a half, the graph will be above. But also when you look at the asymptote, on the other side of the asymptote, this graph is always above. So the quick way to answer this would be just telling us that x must be less than a half, then the graph will be above the x-axis. But also x must be greater than 1. Because on the right-hand side, that's when it's above 1. Because if we only give this restriction here, which means after the half, the graph is probably below, which is not the case. It's just this section that is below. So we need to also give this. So 1 mark probably for the first condition, and then the other mark for the second one. Then the equation of the axis of symmetry of G with a negative gradient. Now they've been specific. Negative gradient. Remember that the equation of axis of symmetry is always y is equal to x plus c or negative x plus c. So we're going to use the negative part of it. For us to get c, we have to use this point here. That is 1 and 2. So where there is y, replace it to where there is x, let's put a negative 1v plus c, so which means ours is a 3. So the equation here is going to be negative x plus 3. So guys, that's what was meant to be done under question number 4. Okay, we move on. Question number 5. Question number 5. The diagram below, in the diagram below, the graphs of f, which is the log function, most cases that we call the inverse in some cases. In this case, it's different. No? So g of x, no, g is the reflection of f in the line y is equal to that. Graph of f passes through this and this, q is the x-intercept, f and r, and y-intercept of g. Now, the moment they tell that it's a reflection in the line y is equal to this, automatically is the inverse. In other words, f is the inverse of g, or g is the inverse of f, vice versa. Okay. Now, first question, they are telling us to write down the coordinates of p prime, the image on G. So if, okay, we have a point, I don't know, somewhere here, maybe somewhere here, or it can even be below, no problem. If that is our p prime, since we're talking about inverses, we're just switching points, okay? What was x becomes y, what was y becomes x. So the coordinates of p prime are going to be 2 and 4. Then can we show that a is a 2? So where do we find a? It's in the graph of f. So we're going to use the points on f. So we know that f of x is the same as y. So I'm going to say f of x is equal to the log ax. Remember we said this is the same as y. So if I try to change this into exponential format, it will be the same as a to the y is equal to x. I'm looking for a. My y is a 2 on f. My x is a 4. And then you can get the square roots on either side. Okay, so square root, square root, square root, square root. So which means a is a 2. A becomes a 2. All right, then we move on. Move on. Remember, they were telling us to show that a is a 2. That's what we just did. Then 5.3. 5.3. Can we write the equation of g in the form? Now remember, g is the inverse of f. So usually, if we have exponential, for us to write it as an inverse, we use the logs, which is log x and that. Okay, so it's the same thing. Let's just switch them around. So since we know that f is the log x base 2, which means g of x is going to be the same as 2 to the x. Just that. Remember, y is log 2 to the x. Switch them around, that's going to be x is log 2 to the y. And then you use your exponential form. Okay, then 5.4, t is a point on f in the first quadrant. T is a point of f. Okay, let me just try to use a different color. Okay, T is a point on F such that the lines are parallel. What this means that if I put my T here and I draw a line, this line must be parallel to that. Okay, interesting. Calculate the area of RTP1. So if I connect this, and then I connect that, so that I have my triangle. Now, someone may argue it's not the right angle triangle, but we can make it one. Okay, how? Because now we're gonna use the coordinates of R, the coordinates of T. How many marks is this question? It's 4 marks. Okay. So first things first, we need to get the value of R, or the coordinates of R. We know that R is on the y-axis. And since we got the equation of G to be 2 to the x, if we replace x with a 0 here, we're going to get a 1. So R is basically 0 and 1. Good. We also need the coordinates of T. But since T, okay, is parallel to the x-axis, which means the y-coordinate of T is going to be a 1. The y-coordinate of T is going to be a 1. And then we can just play around with the values there. So if I use the equation of f to find what x is, so 1 is equal to the log of 2 to the x. What's going to be x there? Chances are high if I change this to exponential, it's going to be 2 to the 1 is equal to x, so which means x is going to be a 2 there. Okay, so I'm having a scenario. Let me just redraw that triangle here, where I'm having 0 and 1. Now I'm ending up with 2 and 1. Okay, but then we said P was 2, was it 2 and 4 or 4 and 2? It was 2 and 4. Okay, so if it is 2 and 4, which means this line is perpendicular to this, it makes it a 90. There's no need to stress. Okay, so if that is true, we need to get the distance, which will be like our height. What is the distance from there to there? So if that is a 2 and 4, so we're looking at 4, and then we're looking at 1. So those are 3 units. Okay, so I'm going to say distance P prime T. So P prime T, that is 3 units. And then the distance RT is going to be just 2 units from there up to there. Okay, and then all we have is just calculate the area. So a half times the base times the height. So a half times 2 times 3. And then that gives me 3 units squared. So that is question number 5.0, as well as the entire question 5. Okay, then we move on to question number 6, probably the last aspect of the functions. So the graphs of f, which is a parabola, and then a straight line, mx plus c, are drawn. D and E are x-intercepts, and P is the y-intercept of f. Turning point is T. Okay, so this did not write it for us. Okay, so let me just reset 1 and negative 4. Okay, 1 and then negative 4. Okay, that now we know. So if that is true, which means for us to answer the first question, they want the range. What is range? Remember, this question is weird. They hardly ask such questions of range and domain. Now it's coming 1 mark. So range simply refers to the y values, any y values that we're going to be looking at for the graph to exist or for the graph to be valid. Okay, so you can see that from the turning point moving upwards. So I'm going to say y must be greater or equal to negative 4. That will represent my range. And then 6.2, calculate the coordinates of D and E. So we can see that D is the x-intercept, E is also the x-intercept. But we know that at the x-intercepts, y must be a 0. So we have to solve that quadratic. Let me jot it here and say that x squared minus 2x minus 3 is equal to 0. I'll open my brackets, that is x and a 3, x and a 1. Put a minus there and a plus is equal to 0, which means x is either 3 or x will be a negative 1. So I know that since x is a 3, which means E is going to be 3 and 0. And then D is going to be negative 1 and 0. The question wanted the coordinates. So you have to indicate the zeros as well. And then they want the equation of G. So we already have these coordinates here, which is 3 and 0. Do we have the coordinates of P? We can get P. We know that P, or at P, X is a 0. So chances are high this is going to be a -3. So I'm going to say P is 0 and -3. How am I getting the -3? Just replace X with a 0 because that is the y-intercept or the y-axis. Okay, so step number 1, when you're getting equation of a line, we need to find the gradient. Okay, so I'm going to say the gradient of PE is change in y over change in x. This is question 6.3. Okay, so our change in y, I'm going to say 0 minus -3 over 3 minus 0. So I'm getting a gradient of 1. So which means my equation is y is equal to just plain x minus a 3. I already have the y-intercept. Okay, and then write down the values of x for which f of x minus g of x is greater than 0. So I'm going to move this g of x that side so that it is f of x is greater than g of x. It's quicker this way. Okay, so what this means that where do I find the graph of f to be above the graph of g? Okay, where is f? This is f. When is f above g? From this point to the left, and then from this point to the right. So I'm going to say 1, x must be less than 0, and x must be greater than 3. So those are the 2 points where the graph has to be greater. Okay, and then 6.5, determine the maximum vertical distance between h and g. Now they are bringing something new. So h is the negative f of x. In other words, it's a reflection of f about the x-axis. Okay, so what we need is to start by getting the new equation of h. So I'm going to say that my h of x is going to be negative f of x. We know that our g of x is just x minus a 3. Now, for us to ever get a distance between 2 graphs, we have to subtract those 2 graphs. Okay, so I'll get negative into x squared. This was minus 2x minus 3. Okay, so for me to get the distance, remember what we said. It will be the h of x minus the h of x. This will represent the distance at any point. I'm going to subtract my g, which is x minus 3. Let me try to simplify this. I'll just take this to be my general formula or my general rule to use. That's going to be negative x squared plus 2x plus 3 minus x plus 3 again. Okay, distance at any point, negative x squared plus x plus 6. Okay, now what did the question asking for? They want the maximum. So if ever they ask for maximum, it's a two-way. We can use the calculus, okay, the application of calculus, where we find the first derivative and then solve for x. Or we can use the turning point kind of approach. So if I use the calculus, I'll find my d prime, which is going to be negative 2x plus 1 is equal to 0. Move the 1 that side, negative 2x is equal to negative 1, which means at a point x is equal to 1. Sorry, x is equal to a half. That's where we're going to have our maximum displacement or the maximum distance between the graphs. Then I'll get this a half and then substitute it back there. Okay, this is going to be negative a half squared. I'll say d max. And then plus my a half plus my 6. What I'm ending up with is 6,25 units. Okay, 6,25 units. So that is what I will get in that case. If somebody wanted to use the turning point, it will be x is equal to negative b over 2a. This is usually for grades, the smaller grades, okay? But in metric, we expect you to use the first derivative. So that's going to be negative 1 over 2 times a negative 1, which gives you also a half. So which means the maximum is at x equals to a half. And then get this, substitute it into the formula of the distance. All right, so that is to do with 6.5. And then 6.6, given that k of x is g of x minus n, determine n if k is a tangent. So now we know that g of x is a straight line, correct? K of x is something extra, which means it's a new graph. And this minus n is just a shift. In other words, this graph is being moved downwards or upwards. But since there's a minus, which means it was moved downwards. So that becomes a tangent at some point. I don't know whether it's at this point or whichever point it is. Okay? We're going to find out that. So they want us to get what n is exactly. Okay, so my thought, by looking at this, I decided to replace g of x with what we have. We said x minus 3, now minus n. So which means that the whole of this is going to represent, let me put a plus there, it's going to represent my intercept, okay, to represent the shift, the change, and all of that. But from this, I know that the gradient is a 1 for this line. And now, if we have a tangent and a graph meeting at a certain point, it simply means that their gradients have to be the same. Okay, the gradients have to be the same. So let me get the first derivative of f. Okay, remember our f was x squared minus 2x minus 3. Is that correct? Is that correct? Yes, that is correct. Okay, so we're saying the first derivative is going to be 2x minus 2. So this is the gradient formula. But now we said that the gradient is a 1. So I'm going to equate this to a 1 and say 2x minus 1 gives me a 1. This is a 2. I'll move the 2 that side, which means 2x is going to be a 3, and then x is going to be 3 over 2. So which means the graphs are meeting at this point where x is a negative. So x is 3 over 2. Okay. Then let me get the y values by just using this f. What is f? 3 over 2. It's going to be 3 over 2 squared minus 2 times 3 over 2 minus 3. If I simplify this with my calculator, I'm getting negative 15 over 4. Okay? So if that is negative 15 over 4, which means this is the point where the two graphs are meeting. Now let me try to determine the equation of the tangent. I'll pretend to be ignorant about the original equation and deal with the new equation of the tangent. So I'm going to use y is equal to mx plus c. Y is equal to mx plus c. Remember, we agreed that the gradient has to be 1. So negative 15 over 4 is equal to 1 into 3 over 2 plus c. I'll move this that side. Negative 15 over 4 minus 3 over 2 is the same as c. My c is becoming negative 21 over 4. Okay. Now, if the tangent is having this y-intercept, I'll go back by how many units did it move. Remember we said negative 3 minus n is representing our c. So negative 3 minus n is the same as negative 21 over 4. And then I just need to make n the subject. So if I move n that side, it's going to be negative 3 plus 21 over 4. Okay? I simplify that, I'm going to end up with 9 over 4, which is 2,25 units. So which means the graph was moved this fraction of distance, or this distance, so that we get, or to make it a tangent. Okay guys, so that is question 6. Then question 7 are telling us that 6 years ago, Tabo bought a phone, okay, at 13,000. The value of the phone depreciated annually according to the reducing balance. This is the keyword. The value of the phone is now this much. Calculate the annual depreciation rate. So reducing balance is 1 minus I to the exponent of n. Let's do the substitution. This is question 7.1. Said A is P, 1 minus I to the exponent of n. This is 8337,75 is equal to 13,000 into 1 minus I that I don't know, to the exponent of 6. So step number 1, I'm going to divide both sides by the 13,000 and then find the 6th root. Okay, how do you get the 6th root? You must press your calculator, the second function, or the shift, and then the square root button. You should be able to get those aspects. Okay, so I'm dividing this by 13,000, and then after doing that, I need to subtract the 1. I'll be left with a negative I. Okay, so if I do that, punch all of this into the calculator, I'm going to end up with negative 0.07135 is equal to negative I. Divide both sides by negative 1, multiply by 100. So I becomes 7.14%. Okay, so that is the answer, 7.14%. Then 7.2, Eric and Tandy need to save 80,000 each to go on holiday at the end of December 2027. Tandy decides that she will start saving at the end of this year, or next year anyway. She will make how many payments? 36. The savings account that pays this rate compounded monthly. Deposits will be made at the end of each month. Okay, Eric calculates that if he makes 48 deposits of this much, starting the end of January, he will have enough money for the holiday. Same rate, compounded monthly. Calculate the difference between the total that Eric and Tandy will deposit in their respective accounts. So, 1, we can get the total of Eric, which is the 1402.31. We multiply it by how many months or deposits? There are 48. We shall get the total. Problem is that we don't know how much deposits Tandy was making. So we need to start by getting the X of Tandy. Okay, so since it is a deposit saving, we're going to use the future value. Okay, so from the future value formula, we're saying X into 1 plus I to the exponent of n minus 1 over I. So it's going to be F times I over this whole thing, 1 plus I to the n minus 1. So how much is needed? It's 80,000. Interest rate is 8.6% compounded monthly over, it's going to be 1 plus 8.6% monthly to the exponent of Tandy is 36. That's correct. To the exponent of 36 minus 1. Okay, when I put this into my calculator, I'm ending up with 1955. It's a 5, not 8. Okay, so 1955.778. Okay, so that's how much Tandy will be paying into the account. So let's see Tandy's total is going to be 1955.778 times 36, and then we said Eric is going to be 1402.31 multiplied by 48. The answers I get, I need to subtract because they want the difference. Since Tandy is making bigger deposits, chances are high she's going to make whatever, a lot of deposits or a lot of money at the end of the 36. And okay, so we're going to say that much minus that. I'm getting 3097,20. Okay, because with tandem I'm getting 70408,08, and then with Eric I'm getting 67310,88. Please, you can confirm that with the calculator. Then when you subtract, this is how much of the difference will be made. Okay, then 7.3. This person was granted a loan of this much. The rate of interest is 9% per annum compound monthly. This person will make monthly payments of this much, starting exactly 4 months after the loan was granted. How many payments will this person settle the loan? Will make to settle? So what needs to happen is that since there is 4 months after the loan was granted, 1 month will be given as an allowance, which means this money is going to grow for 3 months. Okay, so for the first 3 months, this money will be growing. Let's get the new amount now. That's 225,000 into 1 plus the I, which is 9%, we're compounding it monthly for just 3 months. Okay, so when I do that, I end up with the new loan amount, which is 230,100,56. Okay, so let me go down here and say this is my 7.3. So the loan is 230,100,56. Now since it's a loan, we're going to use the present value. This is 1 minus 1 plus I to the exponent of negative n over I. We need the monthly payments. No, we have them. That's 55,000. So we said X is 55,000. I is 9%. We're looking for the N. Our P, we already have it. So that's going to be 230,100,56 is equal to 55 into 1 minus 1 plus 9% over 12 to the negative n. So I'm going to just use negative n because I don't want the number of years. I want the number of payments in months. Okay, so step number 1, it's up to you how you're going to solve this. You can start by dividing both sides by the 5.5. Okay, so that's going to be 230,100,56. It's fine. I'll divide by 5.5 and then I multiply by 9% over 12. It's the same thing, eh? So this must give us, or you want us to subtract 1 straight away. We have negative 1 plus 9% over 12 to the negative n. Okay, so when I simplify my left hand side, I'm getting 0.686227 is equal to, when let me use a negative, it's fine. This is going to be negative 1,0075 to the negative n. So divide both sides by the negative. We're going to end up with a positive answer, and then we're going to use the logs. Okay, 6227 is equal to 1,0075 to the negative n. So when you use the logs, saying negative n is equal to the log of 1,0075. This is going to be 0.686227. Okay, so negative n is equal to negative 50,39. Divide both sides by that, we have 50,39 positive. The question was asking how many payments will this person take. Now this person is going to make 50 payments of 5,500. But then there's going to be an extra payment, so which means it's going to be 51 payments that needs to be made for the loan to be settled. Okay, so that is question number 7. Okay. Then question number 8, they want us to get the first derivative from first principles. So this question was a bit tricky, but it was easier, like it's quick. Okay. So f of x is 1 over x. We need to determine f of x plus h, which is 1 over x plus h. Where there is x, replace with x plus h. So we're saying the limit as h tends to 0. The formula is f of x plus h minus f of x over h. So limit as h tends to 0, we're going to have the 1 over x plus h minus the 1 over x over h. So these are fractions. I prefer using the crisscross. Okay, open that up. So I'm going to say limit at h tends to 0, that's going to be x minus this bracket x plus h over this x plus h into x. Why don't I just open it up once? Okay, so that's going to be x squared plus xh, this and that. Okay, but then I'm dividing it by h. Okay, open the brackets on top. Open the brackets on top. So the limit as h tends to 0, that's going to be x minus x plus h over x squared plus xh. I'm not going to multiply through because I'm seeing something cancelling out. So that has cancelled. I'll be left with h alone. So this h can also cancel this h. Okay. Okay, we can go step by step. Because someone will say, but now, why are you cancelling at the same time? Okay, it's fine. What's going on? Okay, so we're saying the limit as h tends to 0, we have h over, what's happening? My pen is acting up. Okay, let me just write here. H tends to 0. Say h over x squared plus xh over h. So this h cancels that. And then we just substitute x with h with a 0. So you're going to be left with 1 over x squared. Okay. Then 8.2, they want us to find the derivative of this. So start by simplifying. The square root of 4 is a 2. This 6 is reduced by that, so which means it's x cubed plus root 2, and that's going to be x squared. And then when I find the derivative, that's going to be 6x squared plus 2 root 2x. That's what I get. Then here, what we need to do, first split up. That's going to be 3x to the 4 over x squared minus, we have 4x squared over x squared plus 6 over x squared. Simplifying that, it would be the same as 3x squared minus 4 plus 6x to the negative 2. And then for me to find the first derivative of g, that's going to be 6x. It's a constant, it falls away, minus 12x to the negative 3. So this is our answer here. Remember, the question never asks you to give your answer with a positive exponent. So just leave it the way it is, and then you're good to go. Okay, so that is question number 8.2.2. Then 8.3, we're given the equation of a tangent to this graph at x1 is given by this. Determine the values of b and c. So just like we looked at that question of functions, when a tangent and a graph meet, the two will be equal to each other, okay, at the point of meeting. So let's start by getting the coordinates at the meeting point. And I'm going to use x as a 1, okay, and use this equation here. So when I replace x with a 1, y is going to be 9 times 1 minus 9 which is a 0. So which means the two are meeting at a point 1 and 0. Then I can get these numbers and substitute them there. Okay, what is my f of 1? F of 1. Let's see. So that's going to be 3 times 1 squared plus b times 1 plus c. This must give us a 0. Is that true? Yes, because we say the x and y will be the same at that point. So it's going to be 3 plus b plus c is a 0, which means b plus c must give us a negative 3. I'll call this equation number 1. Then I can look at maybe the first derivative, which is the gradient, because I know the gradient of this line is a 9, which means even the gradient of this function must also be a 9 at that same point. So let me change this and say my first derivative, f prime of x, is going to be 6x plus b. Because c is a constant, it falls away. But the x is what? The x has to be a 1 and the y has to be 0. No. The x has to be a 1 and then the gradient has to be a 9. So 6 times 1 plus a b must give us a 9. Because remember, this is the gradient. This is also the gradient. So which means b is going to be 9 minus 6, which is a 3. Then if I put my 3, there is going to be 3 plus c is equal to negative 3. Move the 3 that side, which means c is going to be a negative 6. So that's how I've done that. So start by getting the points here. Substitute these points into f. Get the first equation. Then get the first derivative. Compare it with the gradient of this line. And then you get that. Okay, question number 9. Question number 9, they are telling us that the graphs f is drawn below is that, and g is that at the intercepts. First question, can we show that a is 1, b is negative 3, and then c is negative 9? So the approach to this is 1. When you look at e is an intercept, but at the same point, it's a turning point, which plays a bigger role. That this, if we are to get the factors of that, it's just going to be x plus 1, but squared. And then I'll multiply it with x minus 5. In other words, this is going to be the equation of f. What we need to do, just open this up and make sure that we end up with these values. Then we shall compare with the original. So when I open the first one, that's going to be x squared plus 2x plus 1. Then I'm going to multiply it with this. So when I open this up, it's going to be x cubed minus 2x squared plus x. And then minus 5x squared minus 10x minus 5. This is going to be x cubed minus 5x squared. This and this is giving me a negative 9x and then minus 5. So this is my new equation. When I compare it with the original that was given, which was ax cubed plus bx squared plus cx minus 5, we can see that a is a 1, b is a negative 5, and then c is a negative 9. The d automatically came out. So in that what they, why are they having a 3? So what did we do wrong? For b squared. No. We have to go back. We have to go back. Something's off. Something's off. What did I do wrong? I'll erase this. I'll erase that and reopen this bracket again. So we're saying x and that is x cubed, this and this, plus 2x squared, this and this is plus x. Okay, then 5, and that is minus 5x squared minus 10x minus 5. Okay, so it's x cubed. So this and this is minus 3x squared minus 9x, then minus 5. Why is everything in minus minus? Does it make sense? Maybe, most probably. So the a is a 1, the b is a negative 3, it's not a negative 5. My apologies, c is negative 9, and then the d is negative. So that is how we would have proved that. Then calculate the value of x for which f has a local minimum. So when you talk of a local minimum, they're focusing on the turning point. Okay, turning points. So I'll need to get the first derivative. So that's gonna be 3x squared minus 6x minus 9 is equal to 0. I'll divide through by 3, x squared minus 2x minus 3 is a 0. Open this up, x minus 3, x plus 1. So which means x is a negative 1, or x is a 3. What do they want? The value of x for which it has a local minimum. So which means x has to be a 3 at this point. Okay, the minus 1 is already at point E. Okay, then use your graph to determine the values of x for which the second derivative concavity times the function itself will be greater than 0. So there are two aspects to this. So I can say that my f double prime is greater than 0, or my f of x is less than 0. Second approach is f double prime is less than 0, or my f of x. But why am I saying that? If it's greater, this must also be greater, since it's greater than 0. And then if it's less, then this must also be less than 0. Okay, now where do we find those scenarios? So we already have the first derivative to be this. No, that's not true. First derivative to be 3x squared minus that. And then our second derivative is going to be 6x minus 6. Okay, so if I have my 6x minus 6 to be greater than 0, which means x has to be greater than 1. And then where do I find the graph of f to be greater than 0, to be above 0? It's at this point, where the graph is above or beyond 5, for x above 5. So x must be greater than 5. And then if it's concave down, it's going to be x is less than 1. And then where do I find the graph of f to be below 0? To be below 0 is less than this. So I'm going to say x must be less than 5. X cannot be negative 1. I can use that as well. Okay, x is greater than 5, x is less than 5, and so on and so forth. So those are the sorts of solutions I would have. The 9.4, for which values of t will this have two positive distinct roots and a negative? So which means this graph needs to be moved. Okay, so the t is just a shift within the vertical. So this is going to be negative 5 from f, if x is a 0 everywhere. And that's going to be negative 5. What we need to find is what is the value of the y at the turning point, or what's the minimum value. So if x is 3 for f, I'm going to say f of 3. Okay, what is the f of 3? That's going to be 3 cubed minus 3 times 3 squared minus 9 times 3 minus 5. This gives me negative 32. So this graph must be moved between negative 32 and negative 5 upwards, because if it goes beyond or below that, then we're going to have something different. So I'm going to say negative 5 must be less t, then must be less negative 32. Okay, so that's question number 9. Question number 10, EHGF. EHGF is a rectangle, and we know some properties of rectangles, okay? Is produced x squared, and that is produced to p, this and this and this are produced at m to form an isosceles that is equal to that. So which means this, like this line, is the same as, is equal to that, okay? And then NP is 4, MD is 3. So this is a 3, that's a 4. Then, first question comes, show us that the area of EFGF is this much. 4 marks. So, first things first. When I looked at this question, I was a bit worried. I was a bit stressed on what is going on. But then, they gave us this as a 90. We know that with a rectangle, the interior angles are also 90 degrees. They are perpendicular. What does this mean? It simply means that this line is parallel to that line. Okay? Then, I don't know why this question was asked in paper 1, but it's fine. It's measurements. What does that make that? This line is parallel to that. This creates what we call the midpoint theorem, or triangles that are similar or proportions. That's what we're going to use here for some point, okay? So what this tells us is that if this total distance is a 4, which means that just this section alone is going to be a 2. If that is a 2, then this is a 1. So then I'm going to say that x squared, I'm dividing it by the total here, which is a 2, is equal to this line b over the total, which is 3, because they told us that total distance is 3. Then I need to make b the subject, which is going to be 3 over 2 x squared. So I'm using this and this. So this one is not going to play a big role for me. Let me just use this. So x squared over the total, which is 2, over b divided by that whole thing. Okay, so having said that, then I can go on and get my area. So we know that the length of the rectangle is going to be 4 minus 2x squared. Okay, because this is x squared, this is x squared. I'm subtracting these 2 from 4 to get my length. Now I already have my height as the b, which is 3 over 2x squared. Then I just need to multiply this. So area is length times the width, which is 3 over 2x squared into 4 minus 2x squared. So 3 over 2 times 4, that's going to give me 6x squared. Okay, minus 3 over 2 times 2, that's going to be 3x to the 4. So this is my area, and that's what they gave me. Okay, then calculate the maximum area for the triangle. So for maximum area, we need to find the derivative dA by the x. What's going on? Okay, so I'm saying a by dx. So that's going to be 12x minus 12x cubed. Then I'm going to equate this to 0. Take out what is common. That's going to be 12x. I'll be left with 1 minus x squared is equal to 0. So either x is a 0, and then when I break this down, I'll have 1 minus x, and then 1 plus x. Or I'll have x as a 1, and then x as a negative 1. So these are the possible values of x. Now, the question wants the maximum area. So then I'm going to just get these numbers of mine and try to substitute them into this formula. So what is A0? That's 0. If I use A1, that's going to be 6 times 1 minus 3 times 1 to the 4. Those are just going to be 1s. So that's going to be 3 units. Now they talked about centimeters. So let me just call them 3 centimeters squared. Then if I try to use the negative sign as well, I'm going to end up with the same thing. So which means that my maximum area is just 3 centimeters squared. Question 11. Question 11. Stimuli is moving. Question 11. Two events A and B are such that probability of A is this, probability of A or B is this, and then events are mutually exclusive. So events are only mutually exclusive if there is no intersection, which means A and B is a 0. Okay? So from the formula of A or B, from the formula page, it will be probability of A plus probability of B minus U0. So A or B is 0.52. Our A is 0.4 plus now the B, which we need. So when you subtract that, I'm going to get 0.1. This was 0.4, yes, not 0.42. Okay, let me just double check and be sure. So probability of B is 0.52 minus 0.4. This gives me 0.12. I hope so, guys. 0.12. Okay, let's take that as our answer. Then 11.2, they're telling us that the items that a learner bought at a tuck shop were recorded over a period of time. Probability that a learner buys sandwich S, chocolate C, and juice J, as shown in the Venn diagram. What's the probability that the learner will buy a sandwich? So for sandwich, we just have to add this. You can buy sandwich only or sandwich and something, and so that's going to be 0.09 plus 0.02 plus 0.01 plus 0.04. In other words, the circle of the sandwich, the Venn diagram of the sandwich. That is what we are interested in. So if you put that into your calculator, you get 0.16. That's what I got. Okay, that's what they need. Then calculate probably that learner will buy at least 2 of the 3. Now, when they say at least, they are simply telling us that the minimum is 2. We're not being told of the maximum, so the maximum can even be 3. So the point of interest will be this 3, this 2, this 2, and then that. So which means 11.2.2, we're going to have 0.02 plus 0.01 plus 0.03 plus 0.04. Okay, when you add that up, I'm ending up with a 0.1. 0.01, 0.03 plus 0.02 plus 0.04. Why am I getting 1.1? Let me just do that again. 0.02 plus 0.01 plus 0.03 plus 0.04. How many items say? Yeah, 4. Getting 0.1. Perfect. Okay. Then 11.2.3. A probability that the learner would not buy any of the 3 items. Any of the 3. So which means they want us to look for what is left outside here. So you need to add up everything inside. But now since we already have these ones, the ones that we just got as 0.1. Or we can just look at just the sandwich, which is 0.16, and then we add this, you add that, and then you add that, and then you subtract from 1. Okay, so I'm going to say 1 minus the probability of everything, which is 0.16 plus the 0.04 plus the 0.03 plus the 0.2. I hope that would make sense. 0.16 plus 0.04 plus 0.03 plus 0.2, which is 0.43. Okay, when you subtract that, I'm going to end up with 0.57. That's my answer. Okay, that is question 11.2.3. Then 11.3 itself, they are telling us that we have 7 guitar players, each with a different name. They participate in a concert. In how many ways can the names of the guitar be listed one below the other in the program? So since there are 7, then we're going to have 7 factorial, which is 5040. 11.2.3, I'm telling us that after the performance, the guitar players wait backstage. There is a bench with only room for 4 people to sit on. What will be the probability that the 4 players will be sitting in alphabetical order from left to right? Okay, so besides the alphabetical order, let's just look at how many of the possible ways. Okay, so we shall have 7 times 6 times 5 times 4. Okay, 7 ways to choose the players who will be seated, of the 4 players. That will be like 840. And then for them to sit in alphabetical order, which means it's a one-way thing, then I'm going to divide this 840 divided by 5040, which gives me 1/6. Then during a performance, 7 players sit in a line on a stage. 4 guitar players are female and 3 are male. So female, 3 male. And how many ways can they be seated if the males may not sit next to each other? So for that to happen, that we don't have any males sitting next to each other, the first person must be female. The last person must be a female, because we have an extra female. So this is going to be male, female, male, female, and then male. So since we have 4 to choose from. With the males, it's 3 to choose from. It's going to be 3 to choose from. It's going to be a 2 to choose from. It's going to be 2 to choose from.